Okay, this is part one of a three-part series on ionic nomenclature. This is going to cover monatomic ions and simple binary ionic compounds. Now remember, ions are atoms that gain or lose electrons. Metals always tend to lose electrons. It's based on their valence electrons. So everything in group 1 has one valence electron, so it loses the one electron and gets a +1 charge. Everything in group 2 gets a +2 because it has two valence electrons to get rid of. Everything in group 13 gets a +3 because it gives away 3 electrons. We skip the transition metals, okay, when we go from 2 to 3, because they have what we call multiple valencies, and we will get into that in our part 3 of the series. And then you can move across group 14. We'll get a plus or minus. Group 15, this is when you have 5 valence electrons, so they're going to gain 3 to make that octet and get a -3. Group 16 will gain 2. Group 17 will gain 1 and get a -1. Okay, so monatomic ions, these are one atom ions. Mono means one, atomic is atom, and so it's a one atom with a charge. The rules for naming, the metal's name always stays the same, and you just add the word ion behind it. The nonmetal's name will change, and it will get an IDE ending. So you just have to be able to tell whether one's a metal or a nonmetal. Now on the periodic table, remember the metalloids, which are right about there, separate the metals are to the left and the nonmetals are to the right. Okay, hydrogen is the only exception. It's a nonmetal. Okay, so when we start with this, sodium on the periodic table is Na, and it's right here. So it is a metal, and its element symbol is Na, and it has one valence electron because it's in group 1, so it's going to lose it and become a +1 charge. That is actually the ion formula. And the ion name, since it is a metal's name stays the same, so it's sodium, and then you just slap ion behind it. All right, the next one is bromine. Bromine is here. It's a non-metal, and it's in group 17, so it gets a -1 charge. So bromine's element symbol is Br. Its ion name, since it's a non-metal, we change the ending to IDE, so it's bromide. And we just established that it gets a -1 charge, so it's Br with a negative sign. All right, magnesium is next. Magnesium's right next to sulfur. It's in group 2, so it's going to get a +2 charge. So its symbol is Mg. Its ion name, since it is a metal, is magnesium ion. And then its ion formula is Mg, and we said it gets a +2 charge. Next one is chlorine. When you find chlorine on your periodic table, it is a nonmetal. It's in group 17, so it becomes chloride. And then everything in group 17 gets a -1 charge, so it's Cl with a negative. And then last is oxygen. It's O, and its ion name is oxide. It is a nonmetal, so you change the ending. And it's in group 16, so it gets a -2 charge. Okay, the key to figuring out where the IDE goes, I usually tell my students that for the most part it's the second syllable, so bromide, chloride, oxide, nitride, sulfide, phosphide. Okay, so that's kind of helps students remember where that IDE will go. All right, moving on to binary ionic compounds. Binary, bi is 2, so this is 2 element compounds made of a metal and a nonmetal. Since it's ionic, it's a metal and a nonmetal. The metal gives its electrons to the nonmetal, and they're transferred. So the metal is the cation, and the nonmetal is the anion. Some rules for binary ionic compounds and naming. The metal is always listed first. The metal's name stays the same, like we did with the monatomic ions. And the nonmetal's name gets the IDE ending, like we did with the monatomic ions. Now we're going to do it two ways. We're going to go from the name to the formula and how you do that. And then the bottom half is the formula, and we come up with the name. So to come up with the formula, we have to do a little thinking, okay? We have to figure out what the charges are. So we find sodium on our periodic table, and it's circled in green. It's got a +1 charge. So Na +1. And bromide is bromine, and it's got a -1 charge. So you look at the charges and you think, okay, do they cancel each other out? And if they do, +1 and -1 cancel each other out. It's just one of each, NaBr. And that's the formula. All right, the next one is calcium chloride, so Ca, and if you find it on your periodic table, it's in group 2, so it gets a +2. Chloride is chlorine, it's in group 17, so it gets a -1 charge. Looking at these charges, we want to find the least common multiple of them, okay? So the least common multiple is 2, so you only need 1 calcium, but you're going to need 2 chlorines to make that -2 charge to cancel out the +2, because all ionic compounds are going to have a neutral charge overall. So the formula is CaCl2. You never put the charges in the formula, okay? You just put how many atoms you need. All right, the next one is magnesium sulfide. Magnesium is Mg. It's in group 2, so it gets a +2 charge. Sulfide is sulfur. It's in group 6, so it gets a -2 charge. These two cancel each other out, so you just need one of each. So Mgs. Aluminum oxide, Al, is in group 13, so it gets a +3. Oxide is an O, and it's in group 16, which gets a -2 charge. And the least common multiple of 3 and 2 is 6. So we would have to have 2 aluminums to make a +6, and we would have to have 3 oxides to make a -6. So we would reflect that in our formula with Al2O3. So we need 2 aluminums and 3 oxygens, okay? Again, don't ever put the charge in the formula. It's just the number of atoms. And the last one is lithium phosphide. Lithium is in group 1, so it's +1. Phosphide is phosphorus. It's in group, it's in group 15, so it gets a -3 charge. So 1 and 3, we need 2 more lithiums to make a +3 to cancel out the -3. So our formula is Li3P. All right, doing the reverse when you're coming up with the name, it's a lot easier. You don't have to find the charges and stuff. So we just have to find the cation and the anion. Okay, the cation is potassium, that's your metal. So that's the first part of the name. And then the second part is the nonmetal, or the anion, which is oxygen, and we change it to IDE ending. So the name is potassium oxide. The next one, Mg, is magnesium. That's your metal, your cation. So its name stays the same. And it's bonded to iodine. That's your nonmetal, your anion. So it's iodide. Gets that IDE ending. The next one is Al, which is aluminum. So the metal's name stays the same, aluminum. And the nonmetal is chlorine, and it becomes chloride. All right, calcium is the metal in this one. Bromine is the nonmetal, and we change it to bromide. And the last one is Na, which is sodium. That's your metal, your cation. And it's bonded to nitrogen, which is the nonmetal, and it becomes nitride, so sodium nitride.